Assalamu alaikum. Welcome to this introduction on task 1, which we are going to discuss Ohm's law and Kirchhoff's law. This is part of ELEC1100 directed remote learning for semester 2 2020. So how are we going to go through this task? First of all, the concepts that we are going to cover in this task are Ohm's law and Kirchhoff's law. First, we are going to study Ohm's law, understand it, then Kirchhoff's voltage law and Kirchhoff's current law. We need to study the task first of all, learn the principles from this key material, then you need to go and study the practice examples, then try the exercises by yourself. After that, we are going to apply whatever we learned on the circuits. Now, first of all, let's define the current. The current is the amount of charge that passes through a conductor per unit of time. So it's coulombs per second. So I is equal to dq by dt, where q is the charge and t is the time. So the current is the amount of the positive charges flowing in a conductor per unit of time, whereas voltage is measured as the energy per unit charge. So the voltage is basically the amount of energy needed to separate two charged particles. So it will be joules per coulomb. Now, what is Ohm's law? Consider this circuit where we have a battery, a resistance, and once we connect, we are going to establish a current over here. Now this current will flow through the resistance, and when the current flows through the resistance, there will be a potential difference between the sides of this resistor. So what does Ohm's law state? It states that the electrical current I flowing through a fixed linear resistance is directly proportional to the voltage applied across it, of course, at a fixed resistance value. What do you mean by directly proportional? It means that the relationship between the current and voltage is a straight line. We know that this means that I is proportional to V, or I is directly proportional to V. In order to make this as an equation, we are going to say V is equal to I multiplied by R, or R multiplied by I, where R is a fixed value, and in this case it is our resistance measured in ohms. Now, power. Power is defined as the transfer of energy per unit of time. So power is dW by dt. How are we going to go through this? We are going to say I is equal to dq by dt, V is equal to dW by dq, which we have already explained in this slide. Now we are going to multiply V multiplied by I. If we multiply these two, we are going to get the amount of power, which is the transfer of energy per unit of time. So P at the end, P, the power, will equal to I multiplied by V. So P is equal to I multiplied by V, or using Ohm's law, we're going to find it's P is equal to V square over R, or I square multiplied by R. Example. Calculate the resistance R, which is required to limit the current I to 2 amperes if the potential difference is 6 volts. So using Ohm's law, V is equal to I multiplied by R. We are going to get the value of R, which is equal to 3 ohms. Part B, calculate the power absorbed by the resistor. We're going to find that P is equal to I square R. P is equal to I square R. So I is equal to 2 amperes. 2 square is 4. 4 multiplied by 6, it's 24 watts. Now, series and parallel. This is quite straightforward for you now. The total resistance for any number of resistors connected in series is their sum. And the total resistance, or sorry, the inverse means 1 over. The inverse of 1 over total resistance is equal to the inverse sum of all the resistors. This is when the resistors are connected in parallel circuits. What do we mean by parallel? Means that the circuits, the resistors, they have common points. Okay, the resistors, they have a common point. Over here, this is a point, and this is a point over here. Now let's go to Kirchhoff's voltage law. Kirchhoff's voltage law states that the sum of the voltage drops around a single closed path in a circuit is equal to the total source voltage in that closed path. In other means, the sum of the voltages across this path will equal to 0. Now, you just pay attention a little bit over here. Let me erase here. Okay, so if you see, this is minus here. This is minus plus, so I'm going to draw an arrow. Minus plus, I'm going to draw an arrow. Minus plus, I'm going to draw an arrow. Minus plus, I'm going to draw an arrow. You can see that the direction of the source is opposite to the direction of the resistors. Remember, the current always enters the resistor from the positive side and exits from the negative side. Here, the current is leaving the positive side of the source. So from here, you can see it's minus E plus V1 plus V2 plus V3 is equal to 0, or V1 plus V2 plus V3 is equal to E. Both equations are right, and this is called Kirchhoff's voltage law. An example on Kirchhoff's voltage law, we are required to find the values of V2 and R2. Now, in order to do that, we know the value of I, which is 2 amperes. We know the value of E, or the power supply, which is 50 volts. We're going to say that E is equal to V1 plus V2 plus V3 plus V4. Now, what do we know? We know E, we know I, R, we don't know V2, we know IR3, we know IR4, which is 2 by 7 for all of them. So we are going to end up with R2 equal to 4 ohms and V2 equals to 8 volts from this equation over here. Now, to further illustrate the concept of Kirchhoff voltage law, and by the way, Kirchhoff voltage law, we usually call it KVL, Kirchhoff voltage law. Now, in Kirchhoff voltage law, to further illustrate it, we use the voltage divider rule. The voltage divider rule is quite simple. If you have resistors connected in series, the voltage drop across any resistor is equal to that resistor value divided by R total multiplied by the source over here. Remember, R total in terms of series, here R total will equal to R1 plus R2, since the resistors are connected in series. Here we have an example on how to use the voltage divider rule. Of course, voltage divider rule will make your life very easy. If you can find the current from here, if you can see, we found the current R total first. We summed 20 plus 10 plus 4 plus 6. So we got the total resistance. Then from the total resistance, we found I. I is equal to V over R. V over R, from where did we get it? We got it from this triangle. What does this triangle have? It has V, it has I, and it has R. So if I want V, V is equal to IR. If I want I is equal to V over R. If I want R is equal to V over I. Now, we are going to use the voltage divider rule. We want the voltage across VAB. So VAB is equal to V2, which is this one, multiplied by R2, which is 4, divided by 40, which is the total resistance, multiplied by 80, which is the source over here, and we get 8 from here. Okay, so the power, again, power is straightforward. P is equal to I multiplied by V. Now, the next rule is called Kirchhoff's current law, which we call it KCL. Now, KCL states that the algebraic sum of the currents entering the node and leaving the node is equal to 0, meaning whatever currents enter the node will exit the node. So if I have a node like this is a current entering, these two currents will be exiting, so this current will equal to these two currents. Now, okay, now this is illustrated in this figure as over here. You can see the current entering I, which is having a minus sign, and the currents exiting are I1, I2, I3 until IN. They are all having positive sign. Or in other words, I is equal to I1 plus I2 plus I3 until IN. If a current is entering the node, we are going to give it a negative sign. If it's exiting the node, then we are going to give it a positive sign. An example, consider that I is equal to 3 ampere. So this is I. Here we have 3 amps entering the node. And we have I1, which is 0.5, and I3, which is 1 amp. So we want to find what? Okay, so we want to find what? We need to find I2. Now from here, we know that the current entering the node is equal to the current exiting the node. So we have I is equal to I1 plus I2 plus I3. So 3 is equal to 0.5 plus I2 plus 1. This will give us I2 equal to I3 minus 3 minus 1.5, which is 1.5 ampere. Now, similar to KVL, in KCL or Kirchhoff current law, we have the current divider rule. In the current divider rule, it is Ix, the unknown current, is equal to the total resistance divided by the resistance where we want to find the current at, multiplied by I total. So over here, these are parallel resistors. What is the equivalence for a parallel resistor? It is 1 over R total is equal to 1 over R1 plus 1 over R2 plus and so on. Okay, so R total, we are going to find it. Once you find R total, then we are going to find the values of R1 and multiply them by IT to find the value of I1, which is the needed current. For example, find the value of I1 over here. To find the value of I1, we need to find the total resistance for these 3 resistors, which is 1 over 6 plus 1 over 24 plus 1 over 48. You need a calculator to do this calculations. Once you find them, you are going to find R total, which is equal to 4.363. Now, a general rule, remember this. If I am going to find a total resistance, my resistors are what? 6, 24, 48. They are all connected in parallel. R total is smaller than the smallest. Okay, R total is smaller than the smallest. Which one is the smallest? 6 ohm. So my answer is 4.3. 4.3 is right. If I get my answer greater than 6 ohms, then my answer is wrong. Make sure you keep this in mind. R total will always be smaller than the smallest when the resistors are connected in parallel. So I1 will equal to R total divided by R1 multiplied by I total. We know I total is 42 milliamperes. So our total result will equal to I1 divided by 4.363 divided by 6 multiplied by 42 milliamperes, and we get our answer as 30.56 milliamperes, or 30.56 multiplied by 10 to the power minus 3 amperes. This is all for this task. You need to understand all these concepts. You need then to go to the solved exercises, study them. Furthermore, you need to go for the unsolved exercises, study them. Once you finish, you can discuss with Dr. Mahmoud on the times that are already published on SULMS, which is, hopefully I have the page, yeah. So, which is these times. You can discuss with him on these times. If you want, you can also discuss with him from any time from 4 to 8 during our working hours in the university. We are here to help you. If you have any inquiries, please contact your course coordinator or your TAs who are teaching you. Don't hesitate to contact anybody in the faculty or university. We are here to help you. Hope to see you all soon. Be safe and stay at home. Thank you.